Welcome to the technical review section. Today's project: building a mini jet boat. First, let's see the power of the water jet engine as it tears through the lake surface at the start of the video. Starting with the rough mold, the engineer uses an angle grinder to trim the composite shell. Continuous hand sanding helps create an optimal aerodynamic V shape. An actual test on the water to evaluate the hydrodynamic profile resistance. The engine sucks water from the bottom and sprays it through a nozzle to create thrust, propelling the boat forward. Pulling the boat ashore, he begins to upgrade the structure. The rough mold needs to be redone, splitting the mold frame in half. Now is the stage: fabricating the steel box frame system. Arc welding creates a solid backbone frame to prevent deformation of the press frame. Trimming and measuring meticulously with a tape measure. To ensure perfect symmetry, he uses a rubber mallet to knock off the old foam sheets, to utilize the flat surface as a base. Continuing with the scrapers, pressing the steel bars tight before final welding. The steel frame is precisely positioned onto the shell, reinforcing the stiffness of the entire module. This is a very professional mold construction technique. Tolerances are strictly controlled. Foam padding is lined for shaping. Next is laying a layer of reinforced fiberglass. Catalyzed polyester resin is poured over it. A specialized roller is used to squeeze out air bubbles. The principle of composite structure is the cross-linking of fiberglass within the resin matrix, switching to applying putty on another rough shell mold. This step is extremely labor-intensive. The engineer spreads the putty knife evenly, covering every tiny bubble on the fiber surface, using a scraper to shave off excess putty, creating sharp keel ridges. 4 ridges running along the hull function to maintain directional stability at high speeds. 5. After the putty hardens, the surface is continuously sanded to achieve absolute flatness. 6. Wearing a respirator mask is mandatory when handling putty dust and fiberglass dust. 7. 5. He uses thin strips of material as guides to refine the edge contours more accurately. 6. The degree of finish of the base mold determines the smoothness of all subsequent molded products. Every imperfection, no matter how small, is detected and thoroughly sanded down to the step of applying Miracle Gloss mold release wax. The wax is buffed in a circular motion to create a barrier. Then a layer of dark blue gel coat is carefully brushed onto the surface, already waxed. 6. The specialized gel coat will cure, becoming an extremely hard and super glossy surface for the mold. Continue adding fiberglass reinforcement over the blue gel coat. Dry and flip it over. The engineer uses a cutter to trim the excess edges of the sharp finished blue mold. First, a wet sanding process is applied. The water helps wash away dust for a smoother surface. Cleaning thoroughly with a towel. Now proceed to cast the actual boat hull from the blue mold just made. This time, he brushes on a vibrant red gel coat. This will be the outer color of the jet boat, paying special attention to the recessed groove in the middle of the hull, where the water intake system will be installed. 64. Fiberglass is reinforced again. Must roll tightly to leave no air bubbles. Using the cutter again to trim the flange edges of the red shell. After the composite cures, carefully peeling off the tape from the mold edges to prepare to separate the finished shell from the blue mold. 5. Just a light cut with a knife and a bit of force, and the bright red shell separates perfectly. Excellent. The red hull surface is extremely smooth and hydrodynamically accurate. Using an angle grinder and sandpaper to handle burrs around the edges of the red shell. Carefully peeling off the protective tape on the edges. Preparing for the finishing stage. The plum red composite boat hull has taken shape, perfectly shiny and flawless. Continuing to flip the shell to grind the edges flat, ensuring a precise fit for the upper deck water jet engine. The jet pump is test-fitted along with 2 gray leather seats. The expert uses white foam sheets for measurement, cutting and trimming to build the engine compartment bulkhead. 4. The dashboard is also shaped from Formex, secured with specialized quick-drying glue. 6. This foam structure is very light, but rigid enough to serve as a base for composite coating. 6. 5. Carefully sanding the edges, gluing plastic trim strips along the gunnel. 6. Using homemade spring coils to clamp the plastic trim, waiting for the glue to bond. 7. Applying putty to fill all gaps and corners, creating a seamless transition surface. The upper deck block continues to be sanded. Test fitting the 2 seats to check ergonomics. Applying personalized CNC cut logos to the side. The trim edges are reinforced with more glue. 1. Using a utility knife to trim square rubber pads. These are the vibration dampers for the engine. 2. Surprise! He applies another layer of sky blue gel coat onto the exterior of the boat hull. 3. Evenly brushing on the resin layer near the folds, moving to process the upper deck. 4. The angle grinder neatly trims the excess fiberglass edges to avoid scratches, using a sharp scraper to trim the edge burrs, using an orbital sander to smooth it out. Continuous wet sanding by hand. He is painting the blue base glue onto the red mold surface. It seems he is creating another version, adding more fiberglass and rolling the resin, using the steel roller to squeeze out air bubbles, the key step that determines the durability of the boat hull. The grinder is back to work, sanding the light gray shell edges, drilling holes to position accessories. 4. Using wood clamps to fix the trim near the edge. The 2 workers are processing the upper deck assembly. The blue bottom hull is released from the mold, clean and beautiful. Wiping thoroughly with a damp cloth to remove dirt. Mixing titanium gray gel coat. Applying this resin to the inner surface of the boat curve. Preparing to lay the fiber. 4. Laying down large sheets of fiberglass. Using a brush and roller to force resin through the fibers. The cross-woven structure of the fiber, when fully saturated with resin, will create absolute rigidity. For load-bearing, the titanium gray upper deck is finished. Lifting the upper deck to test fit it onto the blue bottom hull. Aligning the edges for a perfect fit. A close-up of the embossed logo on the stern, very sharp. Grinding down the burrs at the joints. Drilling, creating radial holes to install the water jet pump shaft. This is an extremely critical position. Drilling specifications must achieve millimeter precision. Using a hole saw to cut the engine shaft mounting hole. The jet pump assembly is placed into position. 1. Applying silicone sealant to seal the flange. Installing U-shaped rubber trim around the gunnel edge. 1. The rubber trim serves to dampen vibrations and protect the composite edges, cutting the excess with scissors very cleanly. 2. Using a plastic card to press the rubber gasket tight, locking it onto the edge rim to ensure adhesion. 3. Joining the upper deck to the gray bottom section, using a mallet to lightly tap the 2 modules into a tight fit. 4. Inside the compartment, the engineer rolls resin and fiberglass to seal the seam line connecting the 2 hull halves. Installing 2 waterproof synthetic leather seats. The ergonomic design is extremely well thought out. 2. Threading the Teflon-coated steering cables through the bulkhead. This cable system will transmit movement from the handlebars. Tightening brass nuts to secure the cable housing. Rubber gaskets ensure the engine bay is completely watertight. Flipping the boat over, he attaches the steering guide rod clamps and tightens the bolts. The intake grate. Wiping the hull clean, Installing the rubber universal joint for the drive shaft inside the compartment. 4. This cross-type flexible joint helps compensate for tolerances in axial alignment between the engine and the jet pump shaft, using a Dremel tool to cut a slot in the side of the hull. Preparing space to install the gear shifter assembly. Positioning and reinforcing the shifter mount. Installing the throttle lever assembly and its cover. 4. Putting on the lever protection cover and screwing it in. This lever mechanism operates easily and very smoothly. The power center, lowering the compact two-stroke engine, but with high output, into the engine bay. The engine block is mounted on anti-vibration rubber mounts, inserting an additional rubber gasket around the lid for waterproofing. Fabricating the telescoping exhaust system. The engineer uses a TIG welder to join the steel pipes to create the muffler. 4. Precision welding with argon shielding gas creates extremely smooth fish scale welds, ensuring no exhaust gas pressure leaks. The water box muffler plays the role of cooling and suppressing noise from the high-revving two-stroke engine. 1. Placing the water box into the hull, a design that optimizes space in the tight engine bay very effectively. Connecting the engine exhaust manifold to the muffler, using a heat-resistant curved silicone hose, and tightening the hose clamps. 2. Locking all the clamps tight. The exhaust line must be airtight so toxic gases don't linger in the bay. 3. Moving to the step of bending handlebars with a mechanical pipe bender, creating precise ergonomic angles. The stainless steel bar is bent into a U-shape to create the mount. The steering system has a strong sports racing style. 4. Processing the engine hatch cover by pouring resin to shape the edges, then brushing on base resin and laying fiberglass. 5. The roller saturates the fiber mesh with polyester resin. The intake shell is thin and light, but possesses excellent rigidity. Casting the hinge mount of the cover with steel bolts submerged in yellow epoxy resin. Bending and shaping the steering shaft bracket. Six. The engineer continues to bend the U-shaped steel mount, tack welding it to the steering shaft. 6. The steering shaft is inserted through the bushing on the hatch cover, connecting to the bearing support. Tightening the lock nut. The steering shaft operates smoothly thanks to the lubricated bearings. Threading the steering cables through the hatch cover slots. The threading process requires dexterity. Closing the engine hatch integrated with the steering shaft onto the hull. An extremely breakthrough design. 4. Screwing down the accessory handles. The handles help the driver maintain balance during turns. 5. Threading the cooling air ducts. Installing the 12-volt battery into the stern compartment. 6. Closing the aluminum cover to protect the battery. Equipping the seats with 2 leather-wrapped headrests. 6. Installing aerodynamic rear-view mirrors, improving all-around visibility for safety at high speeds. Attaching the aluminum CNC brake assembly. Wrapping paracord around the handlebars to increase grip. Burning the end of the paracord to secure it. Linking the jet steering cables to the hand levers. Opening the engine cover to check the cable travel. The cable pull will deflect the jet nozzle direction. 4. Securing the main exhaust muffler. Installing the cooling water line circulating for the engine. 5. Tightening the aluminum fuel cap. Connecting the fuel line through the filter to the carburetor. 6. The titanium gray mini jet boat masterpiece has finished its extremely aggressive look. 7. A 360-degree rotation shot, showing off every aerodynamic detail, sharp and modern. 2. Towing the boat to the dock with a trailer. ready for the actual test run. 3. Refueling with the pre-mixed gas and oil typical of high-power two-stroke engines. 4. The filter funnel helps remove impurities, protecting the combustion chamber and carburetor. 5. The bow compartment is spacious enough to store life jackets. Starting the engine, exhaust smoke blasts out powerfully. The engine roars as the boat is pushed into the water. Excellent V-shaped whole keel structure. 6. Get on board and enjoy. The low center of gravity makes the boat extremely stable on the water. 7. Throttling up. The jet pump sucks water and blasts it out the back, creating incredible forward thrust. The boat glides away smoothly. The two-stroke engine power provides instant acceleration response. The composite hull is light yet strong, gliding smoothly through sharp and narrow turns. The jet engine doesn't use an exposed propeller, so it easily navigates through shallow waters. Artistic light drift turns, splashing water beautifully, proving the perfect power distribution design. 4. Wind-tearing acceleration capability. The power-to-weight ratio of this jet boat is excellent. A personal fabrication project of professional scale. Thank you for watching.